All right, so here we're doing row sales. So a street vendor constructs a table below on a basis of sales data. So we have this data down here, and we're supposed to find a model for the quantity sold. So we're going to have sales sold based on the price. Okay, so we're going to have some, probably we'll call it maybe S of X, and that's going to be in dollars. Then we're going to construct a model for consumer expenditure, which is also called revenue for the vendor. So if we're going to call it revenue for the vendor, and below here it says what should the street vendor charge to maximize revenue, I think it looks like revenue is going to be a better way to call it instead of some expenditure. So we'll call that R of X. And then if each dozen roses costs the vendor $10, what price should he charge to maximize his profit? Well, profit, remember, is going to be equal to, we should probably put P of X here. Profit is equal to the revenue, R of X, minus S of X, and then this is a value we have to multiply it by another thing, and we'll have to multiply it by that cost there, so times 10. So what we're going to do now is we're going to fill in these values based on what the table here says. So let's go to our calculator to get the model we need. So if we plug that in, I plugged it in prior to this, so now we can look at our graph, and it looks like it's going down. And it could be going down the other way too. So let's start with quadratic, see how it fits, and go from there. So that's 5, and let's put our equation in var1. That way we can actually use it later. And so that's what we get, 0.7151625 and 31.509 and negative 185. So what does that graph look like? Well, it's not the best in the world, but I think with the choices we have, I'm going to stick with that one because most of the others I believe are going to be way far off compared to that even. So that's going to be our S of X. So let's go ahead and go type that in to or write that in our table. And so if we go out to 3 decimal places, that should be good. So that was a negative 0.715x squared plus 31.509x, and then minus 185.615. And this is, let's see, that was in model for quantity sold, dozen roses. All right, sold by vendor. And see, what are our constrictions? Our price for $20 to $32 being the price that it's in that range. Okay. All right. So now, what is R of X? Well, that's going to be our revenue based on how many we sell. So if we take and multiply S of X times 10, that will give, or not by 10, by X, that will give us what our revenue is. So if we multiply this equation by X, that's going to make that X cubed, X squared, and X. And so that'll give us a negative 0.715X cubed plus 31.509x squared minus 185.615x. And now this is going to be dollars in revenue by the vendor at X. Well, at and X don't look good there. At, well, at X from, again, $20 to $32. Okay. All right, so that's going to be our R of X. Now, our P of X is going to be this R of X minus this S of X times 10. Now, when we do that, we can probably put that in our calculator and we won't even actually have to, do a lot of the typing it in. We can type it in once in S of X, then we can make an R of X by multiplying that by an X, and then we can say, okay, well, then take the next one and then minus the S of X times 10. So we can do a lot of manipulation in our calculator because when we start doing rounding, we're going to get a rounding error based on this. So if we can make everything based on this, then we can make it a lot easier. So this one is our S of x. Well, let's go ahead and say, well, then this one is going to be y1 times x. And so that would be what this one is, and that's going to be our r of x. Now, can we make our p of x easily? Well, p of x, that's going to be r of x, which is our y2. So that's going to be var, and then we'll have enter, we'll have our y2, and then we'll be subtracting our y1 times 10. Okay, and so that will give us the function. And so if we look at our graph, we should get, a whole bunch of different things here. And it's drawing the blue line right now, and then it'll draw the others, and we'll have to see if we have to move up and down on that, because we probably are going to have to, based on our values, because we're going to be multiplying by x. So our x, and they're going to be the same, but it's our mins and maxes. So let's go from 0 to maybe, I don't know, let's go to 2,500, because I don't know how high up it's going to go. Well, we almost got there. All right. And so that's going to be, and then where is our, that's the P, that's our S, and our R. Wonder where our R is. So let's maybe go to a negative 250. I don't know where it is. I don't know if it's down below there or not. Huh. Anyway, what is our, make sure. It's y1 times x is going to be y2, and that's red. Well, anyway, it's giving us this one, so that should be, we should be okay. So let's start doing what we need to do for the thing. We'll find out if we've got everything we need. All right, so we've got the quantity for the model sold. So that's our A. We're good there. Construct a model for consumer expenditure, revenue for the vendor. Well, we just took S of x times x, and we got this one. So that's our B. Now with B, now we really, this is kind of the first part of C. So with B, maybe let's go ahead and we have to now take that derivative. So for C, we're going to take and find r prime of x. And so we're going to have to multiply and do that. So we'll take 3 times that, and that's going to give us a negative, let's say 15, so 2.145x squared, and then plus, and that's going to be double that, so it's going to be 60, 3.018x, and that's going to be minus 285.615, and that x drops out. And so, yeah, so is that, oh, that's a 185, not a 2. That one looks like a 2, so I better change that to a 1 so I know I have the right thing. And so that's going to be my r prime. And so what I need to do then is I need to find what those values are. So I'm going to have to find x and x, because there's going to be 2 because we have the x squared. But in this interval between 20 and 32, I'm not exactly sure if there's going to be 2, but we can see if there is. And so let's see here. I'm sort of concerned about that red one not showing up. So maybe, where do I want to go to? Maybe minus 500. I don't know where it is. So anyway, so let's go ahead and do our math and do our problem solver here. And we're going to take the derivative of the first one, y1 times x, and let's see what we get for that and see if it's working or not. So let's plug in, and we know it's from 0 to 32, so let's plug in 32 and see what we get. All right, so we get 26.0515. That looks right. Now for our low end, that was at the, what was that, 20. So let's see, what if we get 20 in here? That still takes us to 26, but what if we plug in a small number? What if we plug in 2? Okay, so see here we have this second one. Our second one is outside of our range. And so we have, after we've done it, we found that x was equal to the 26.0515, and do we want to round it to 6, or I would just put 7. And then that other one was 3.3208. But this is outside of this range. And so I'm going to say, well, let's drop that. We don't need that one, so we'll drop it because it's not going to be within the range we need. And so what we are going to need is f of 26.055157, f of 20, and f of 32, our endpoints. All right, so let's plug in those values and see what we get. All right, so going back to our calculator here. Now, if we go back here and put in our 25, and we find that it's 5157, so that should be enough because then it goes to 0. So let's go to our graph again. And what we want is on our blue graph, we want to find what those values are. So let's turn off this one, and let's turn off this one, and then we can go and not go as far. We can go from 0, and then I think we can go to maybe 250. I don't know what our value will be, but maybe that'll get us into the region. Yeah, there we go. And so what we want to do, because we're between the 20 and 32 now, and so what we're going to do is we're going to say, okay, calc the value. Let's do 20 first. So we get 158.5019. So that's going to be our 20. Now, we're not doing the right one because we need R prime, and that's S prime. So we need to actually have the second one on, not the first one. So that was my mistake. And so let's turn that one on. And maybe let's not put that prime there. And let's see if that gives us anything. Now we'll have to put that window up higher. All right, let me pause and get this to come out. All right, so it was just up higher than I thought. I thought it was only around 3,500. It was at 4,500 almost. So that was our key issue. So what we need to do then is do our value, and we had our value was 26.05157. That gives us 149.87. Oh, we went on the red line, not the blue line. 3904.533. Okay, so that's going to be our value with the Y1 times that. That's our revenue. And our other one we needed was 20, and that's 3170.0398, and then we needed the 32, 2891.2011. So now we have those values once we found where the graph was, and let's write those down. So we have now for this one, 3904.5332. This one, it was 32 or 20, okay. 3170.0398, and 32 was 289. Oops, let's write it down a little lower. And that was 2891.2011. All right, so now we have those. So those are our points. And so what price should the street vendor charge to maximize a consumer expenditure? Well, the one that makes the most money here. Excuse me. And so that one would be the absolute max. Okay, and so if we converted this to dollars and this to dollars, if they put it at 2605 per dozen, we would get 3904.53 dollars out. So that was in our order point though. And so that would be maximizing the charge for the consumer to get the most money out for the vendor. Okay. Now the last one is the R of X minus S of x times 10. And I think that one was working for our calculator because we had, the only issue was we weren't going up high enough. And so now we can turn off that one and we can go probably not as high if I remember right. Yeah, so we can go up to, let's trace, so we can go up to like less than 3,000. So let's shrink that down to maybe 29, I don't know, 100. Hopefully that's slow enough. Yeah, there we go. All right, so now what we want to do is we want to basically, well, we better go back and read what it says. We want to, what price should he charge to maximize his profit there? So we want to maximize the profit there. And so let's go back over here. And so that's going to be where we need to look at our math again. We'll go up here, do a numeric solver. And now it's going to be, oops, we're going to be doing our, let's see, that was going to be y2. And then it was minus, we better put an insert here. And then that was our s of x, which was 1, so y1 times that and the derivative. And so we'll go okay. We'll say okay for 32. And so that is telling us 32, but I'm thinking there's an issue with something here along the way. Maybe because we didn't, maybe we should turn all of these on. Maybe that will help. All right, so it's the y2 minus y1 times 10. Y2 minus y1, oh, times 10, not x. That was the issue. And then we'll insert again, times 10. And then we can delete that. And now when we do it, hopefully that's going to be a little better. All right, 27.576132. And let's see if we put in maybe a 2, what does that give us? Oops, it doesn't give us anything pushing that button. 8.46, but that's not going to be a value that makes sense because that's below our 20. So that one is not going to work. We're going to actually want to use the one closer to 32, which was the 27.57613. And then while we're here, let's go back to our graph and find what that is on the black line. And so that would be, we're going to find the value, and that was at 27.5763132 or somewhere about thereabouts. And so that gives us, if we get to the black one, 2450.8842. Okay, so that's going to be our value. So those two values are what we need. And so we're out of room here. So now let's go over here. And so P prime of x was going to be basically our derivative we did on the thing. So we set that equal to 0, and we found x was equal to 27.576132, and f, or what I guess we want the p of 27.576132 was going to equal, it said 2450.8842. And so that means if we set the charge at 27.58, we're going to get the max of 2450.88. Okay. And so that's going to be that if we pay $10 per dozen. Okay. Now the key here is we didn't actually do that calculation for the derivative there because that would have required us to do this here calculation. We had to take this number and minus this times that, which is not hard. It's all little numbers. But again, when we do that, it's going to be basically, we can do simple, going from here to here, and we get numbers, but they're rounded. And we want to get a more exact answer using all the decimal places. So this time I decided for finding P prime, I'm going to use the calculator directly. I'm not going to take this and then subtract 10 times this, which would be easy. You just have 10 times that. So it'd be a minus, a minus, a minus. So it's going to be plus 7.5 15x squared, and then it's going to be a minus 10 times that, so it's going to be a minus 315.09x, and then it's going to be a minus times a minus, so it's going to be a plus 185.615. Okay, so then we'd add those two together, and then we could just take the derivative again. We'd take 3 times that, and then take that to 2, and we'd take 2 times whatever that sum is, and then that's a 1, and then 1 times whatever that sum is, and that would be it. And then that would drop off, and we would have our derivative, and then we could plug that in and simplify. But again, once we start doing this, we're losing decimal places and everything. So I think doing it with the calculator in this instance makes a lot more sense. Okay, and so that should give us, if the roses cost the vendor $10, what price should he charge to maximize his profits? He should charge $27.58 to maximize a profit at that value there. That would be our absolute max. Okay. All right, so let's stop there, and I'll come back with one more.